Hi, hello everyone. I am Sham. I'm a maths and science tutor for GCSE level, well, secondary school level, so year 7 to year 11. And today we are looking at atomic structure. Let's get right into it. I'll keep this short and sweet, no nonsense. Let's just get into it. To talk about atomic structure, first we need to understand what atoms are and what do we mean by structure. So, atom. What is an atom? Well, if you look at your hand and you zoom in, you're going to see your muscles, right? You're going to see your veins, you're going to see the blood, you're going to see the cells. And if I just keep zooming in closer and closer and closer, eventually I'm going to see the smallest possible thing, right? And what is that thing? They are atoms. Okay, so the proper definition that you need to learn is that an atom is the smallest particle of an element that can exist. Now, what's an element? Okay, so this is a periodic table and it shows us all of the elements, okay? Every element is just a different type of atom. So you can think of it as like building blocks, Lego blocks. You can think of it as Lego blocks, okay? So basically, an atom is a Lego block. And obviously, when you build Lego, there's a lot of different kinds of blocks. You have red blocks, you have long blocks, you have short blocks, you have Minecraft blocks, right? That you have so many different kinds of blocks and that you can kind of think of elements that way. All elements are atoms, just like all building Lego blocks are building blocks. So I might have iron, I might have oxygen, I might have hydrogen, I might have copper, okay? And these are all just different kinds of blocks, but they're all blocks. So all of the elements are atoms, okay? And elements are just different atoms. Nice and simple. I know I might be repeating myself sometimes, but it's just to drill the idea in a little bit, okay? So stick with me. So now what do we mean by atomic structure? Well, by structure, I just mean how is it built, right? Like when you hear the word construction work, building work, right? Building stuff. So the structure is just about how something is built. An atom looks something like that. So the idea is that there is something in the middle. And we call this middle part a nucleus. Okay, so this is my nucleus. The center of the atom. That's where most of the mass of the atom is. So I'm just going to label this as my nucleus. And you might be wondering, okay, so the center thing in the center is a nucleus. So what's all of these weird lines around it? Well, we call these just shells or orbit, okay? I think it's better to call them shells, but you can kind of think of it as an orbit. Why orbit? Because it's kind of like a planet. Everything in our solar system orbits around the sun, right? The Earth orbits around the sun. So we could call these lines orbits, which these lines show us where the planets actually go, how they move around the sun, okay? So that's essentially what these lines are, drawn around an atom. It's actually very similar to a solar system. So we have a nucleus, which you can understand as the sun, and then we have the lines that orbit around it, okay? I think it's so much better to call them shells, okay? Shells. So the nucleus actually contains things inside of it, and it contains two subatomic structures. Okay, so the green ones, it doesn't matter what color they are, I just made them green because I like green. So I'm gonna call the green ones neutrons, okay? So inside of the nucleus we have neutrons and we have protons, okay? So that's it. So we have protons and neutrons inside the nucleus. So if you remember, we have a shell, which is the line around. So what's the thing that actually orbits around it? We call these electrons. I should have made the electrons blue to be honest, but that's all right. I'll make them a light blue, okay? See, so we have these light blue circles that actually orbit around the nucleus. And what are these called? These are called electrons. Bang. So, again, I have a nucleus in the center. I have a shell around the nucleus. Now, my protons and neutrons are inside of the nucleus, and my electrons orbit around them. We actually call these the subatomic structures. Okay, going back to the periodic table. There's so many different kinds of elements, which are basically atoms. So I could say there's so many different atoms, right? Now, what's the difference between all these elements? Well, they just have different amounts of electrons or protons or neutrons, okay? So obviously iron and calcium, they are just, the only thing that makes iron different from calcium is the amount of protons, neutrons, or electrons that they contain, right? And that's why we have a periodic table, because it organizes these things nicely for us. So it shows us how many electrons this one has, how many electrons that one has, and neutrons and protons as well, okay? Different amount of electrons, protons, neutrons change the properties of the element. Now there's a few more things that we need to say about electrons, protons, and neutrons. So I'm going to start off with electrons, okay? So we need to understand that electrons have a negative charge. They have a -1 charge, okay? They have a negative charge. And we need to know that they weigh basically nothing. So you could say that they weigh 0. By the way, so in chemistry, we use the word mass for weight, okay? So you're going to hear me saying mass. Whenever I say mass, I'm basically saying weight. So the mass of electrons is basically 0, but we shouldn't say that. Obviously, it does have some kind of mass, and the mass is 1/18740. 1/1/840. Very, very, very tiny. And that's why some people say that it's 0. It's just because it's so small, it's negligible compared to the protons and neutrons, okay? Now, neutrons don't have a charge at all. They have a 0 charge. They are neutral. They're neutral. Thus the name, right? Neutrons, neutral. Neutrons, neutral. They don't have a charge. However, they do have a mass. Unlike electrons, which have negligible mass, the neutrons have a relative mass of 1. All right, that's all we need to know. 1, that's the mass. And finally, we have protons. And protons are positive. Positive. It's kind of in the name as well, right? So they have a positive charge, so +1 charge. And they also have a relative atomic mass of 1. So it's easy to remember. Protons, 1 mass. Neutrons, 1 mass. Electrons, basically 0 mass, or 1/1840. Tiny. And the charges, protons +1, neutrons 0 because they are neutral, and electrons -1 because they are negative. Protons are the positive ones. So I actually like representing the stuff I just said. I actually like representing the information I just talked about in a table like that. So here are my subatomic structures, protons, neutrons, electrons. Now here's my relative atomic mass. And if you remember, protons have a mass of 1. Neutrons have a mass of 1, and electrons basically have no mass. So I'm just going to say either 0 or 1/1/840 to be more precise, but basically 0. It's negligible. Now, what about the electric charges? So I know electrons are the negative ones. So electrons have a -1 electric charge. Now the neutrons are neutral. So they have 0 charge. And finally, we have protons, and protons are positive. They have a +1 charge because they are positive. All right, so I like memorizing this table. I think it's one of the best things you can do. Very, very useful. All right. Okay, so here are some elements from the periodic table. So if we have a look at lithium, we have these 2 numbers. Top number is the mass number, actually the relative atomic mass number, but I'll just keep it simple for now. And the bottom number is the atomic number. And if you see that every element has one, so sodium has 23 and 11, magnesium has 24 and 12, every element has these 2 numbers, one at the top, one at the bottom. But the mass number tells me how many protons and neutrons there are. I know that protons have a relative mass of 1. I know that neutrons have a relative mass of 1. But electrons are negligible. We don't care about them. So the whole mass of the whole atom is made up of protons and neutrons, not electrons. It's only protons plus neutrons. So the mass number is basically just protons plus neutrons. No electrons. So the mass number tells me how many protons or neutrons there are. Now if I look at the bottom number, that's the atomic number. And the atomic number tells me how many protons there are. Okay, so the top one. So I know that there's 3 protons. Now, if you remember about the electric charge, all elements have a neutral charge. Okay, neutral. What does that mean? That they're not negative, they're not positive. They're just neutral. They're just chilling, you know. They're not positive, they're not super jolly, they're not very depressed, they're not very sad. They're just chilling. They're neutral, okay? All elements on the periodic table are neutral. So what's the idea here? So if lithium has 3 protons, if it's positive plus 3, it's going to have 3 electrons to neutralize, you see. So the atomic number tells me how many protons there are. It also tells me how many electrons there are, right? Because as I just explained, the number of protons has to be equal to number of electrons. Therefore, lithium has 3 electrons, it has 3 protons, Now I can figure out how many neutrons it has. How? Because if you look back at neutrons, because if you look back at the mass number was 7. And I know that it has 3 protons. And I also know that the mass number is made up of protons and neutrons. So since I know that there's 3 protons, how many neutrons are there in all? It's just basic maths. So look, protons plus neutrons equals mass, right? The total mass. So if I know that there's 3 protons, and I know that the total mass is 7, then how many neutrons are there? Oh, obviously 4. You see that? So to figure out how many neutrons there are, all you have to do is take away the atomic number from the mass number and you'll know how many neutrons there are. So there must be 4 neutrons. And this works with every element in the periodic table. Hopefully this gave you a little introduction to chemistry. It's one of the most basic things you need to understand when you start chemistry. And yeah, this was atomic structure. Make sure to leave a like, subscribe, and comment what other topics you would like me to do. And yeah, hope you guys enjoyed. Take care.